All right, so welcome to our flipped classroom. Today we're going to begin Unit 3, which is our algebra unit, and we're going to start with some exponent law review. So hopefully you remember these laws from last year. And then we're going to learn one new thing to do with exponents. Okay, so first we have our multiplication law. Hopefully you remember the rule from last year. Basically it says when we're multiplying two powers, we want to keep the base. Okay, and we want to add the exponents. So two real simple examples. You'll remember then that this equals x to the 9. And you'll remember here that we still multiply the coefficients, so we end up with 12. And then with the powers, we have a, and we keep the base, and we add the exponents, so we have a 7. Okay, so that's our multiplication law. And then we have our division law, okay? Again, I like to say this one as when we're dividing two terms with the same base or two powers, we keep the base and we subtract the exponents, okay? So really quickly, this one, of course, equals x to the 4. This one, we still divide the coefficients, the numbers as normal, so this equals -5, a to the 3. Okay, and the last law that's a little bit different is called the power law. And this one, we actually, if you recall, just multiply the exponents. We keep the base, but there is only one base, and we multiply the exponents. So this one equals x to the 10. And this one, the one thing here not to forget is that this exponent of 3 applies to the 4 as well. So we end up with 4 to the exponent of 3. And we end up a squared, which is also to the 3. We don't need to write that line, but this ends up equaling 64, a to the 6. Okay, so hopefully those you remember from yesterday and from last year. And in class, we'll spend a good amount of time practicing some of those to make sure that we remember them. So today we're going to learn something new as well. We are going to add and talk about what are called negative exponents. Now you might have saw zero exponents last year, but if not, we'll definitely touch on those as well. Okay, and hopefully you can see my table here. Nothing should be too complicated in the table. So 2 to the 5 equals 32, 2 to the 4 equals 16, 2 to the 3 equals 8, 2 to the 2 equals 4, 2 to the 1 equals 2, and then even if you want, just using your calculator, if you punch in 2 to the 0, you'll see that it equals 1. Okay, if you punch in 2 to the negative 1, you will see that that equals 0.5. Okay, if you punch in 2 to the 2, you will see that that equals 0.25. And if you punch in 2 to the negative 3, you'll see that that equals 0.125. Okay, and if I take these and I actually write these as powers, okay, you will see that this, let's start down here at the 0.5, this actually equals 1 over 2. This actually equals 1 over 4. And this actually equals 1 over 8. And maybe then you might notice that this is obviously 1 over 2 to the 1. This is 1 over 2 to the 2. And this is 1 over 2 to the 3. And that is our negative exponent rule. Okay? So basically, when we have a power with a negative exponent, we can rewrite it as 1 over the same power, but with a positive exponent. So the answer will always be a fraction. Okay, and you might have recalled, like I said, the zero exponents from last year. Anything to the exponent of 0 equals 1. Okay, and that is a rule that you'll just want to put to memory, and it doesn't matter whether it's 272 to the power of 0, it still equals 1. Doesn't matter. Okay, so let's try a couple of those and see how those negative exponents come into play. Okay, so let's look at a few questions and how we're going to work with this idea. And again, we're going to practice a lot in class. So pay attention to the wording of this question. It says, use the rule for negative and zero exponents, write as a power with a positive exponent, and then evaluate. Okay, and note these are 2-mark questions, so you will always need to have the in-between step where you write as a power with a positive exponent. Okay, so here's what this looks like. If we take the question 4 to the negative 1, we know that we can make that a positive exponent by doing 1 over 4 to the positive 1, and then obviously that one just equals 1/4. So we always would leave our answers as fractions, no calculator really necessary in this case. Okay, looking at example B, we would write it as a power with a positive exponent, so 1/3 to the 4. And then we, of course, get 1/81, because 3 to the 4 is 81. So that's how we evaluate. Now, if we do the fraction one, okay, I will write it out the long way. This means 1 over 2/3 to the 2. Okay, and if you go through actually dividing fractions, you will see that that actually becomes 3/2 to the 2. So you actually just flip the fraction to make it a positive exponent. And then, of course, that one would equal 9/4. Okay, so we'll practice all kinds of those. Let's look at the last example here and see here now I'm just asking you to simplify and express everything with positive exponents. So just like all of our questions last year, things will usually tell you to simplify, and anytime you get a negative exponent, you just rewrite it as a positive exponent. Okay, so looking at a very simple question like we've seen before, this is of course using our multiplication law, and we get x to the -3 when we add our exponents, so then we always would rewrite our answer with positive exponents, and it would look something like that. Okay, looking at example B, we know that this one has a fraction in it, so to get this as a positive exponent, we would actually then flip it. Okay, and that becomes a positive 2. Now we know that that power actually applies to both the y term and the x term. So what we have is we have y to the -6, that's the power of a power, or the power law, over x to the 4. And then if we want to take this negative exponent and rewrite that as a positive exponent, it actually moves to the bottom, right? Because it becomes 1 over y to the 6. So it actually ends up becoming 1 over, we have our x to the 4, and then we have our y to the 6. Okay, so the y to the 6 actually moves to the bottom because it becomes 1 over that. So hopefully that makes sense, and like I said, you'll be doing a whole page of these in class to practice lots and get to ask lots of questions in class. Thanks for listening.